Hello. So I'm going to be. This is going to be diving into the code a little bit. I'm going to be looking at some C# code, and I'm going to be looking at some very specific techniques that you can use when you're working with legacy code. I'm going to be looking at how you can use code coverage and mutation testing to add tests to legacy code that doesn't currently have any tests. There are some useful links under this QR code, and I will share that again at the end. So don't worry if you don't manage to grab that now. I know what it's like. It's like, oh no, the QR code, I've got to get my phone. Oh no, it's too late. Never mind. It's all right. I'll show you again later. So when would you do this? One of the things that I talk about a lot, so it's one of the things that I work with when I'm training people, when I'm doing technical coaching, is I'm helping teams to get good at refactoring. So refactoring, I think, is an incredibly important skill. And weirdly, it's one that people don't tend to learn, even though it's not actually trivial. It's not an easy thing to do. It's just making things better. And you know how to make things better, don't you? You know when there's something wrong and you know how to make it better. Well, actually, no, there are lots of techniques that you can learn specifically to refactor. And when I say refactor, what I mean is making your code easier to understand and cheaper to modify. So I'm not talking about changing what your code does. I'm talking about making it easier to work with. And what's really common is that people have refactoring jobs that need doing, and they put them on the backlog. And they say, oh, yes, we all agree on this team that this bit of code over here needs refactoring because it's not easy to understand and it's not cheap to modify. And it takes us ages to fix bugs in it, and it takes us ages to add new features. And we'd really like to make it better. But it seems like this horrible, big, enormous task. So we've put it on the backlog. And the longer you leave it on the backlog, the bigger the job gets. And then the more likely that you put it off. And then the bigger it gets and the more likely you put it off. And it just becomes this horrible thing that nobody wants to touch. So when I talk to people about refactoring, what I talk to them is about how they can do refactoring in tiny steps. So they can just gradually make code better rather than trying to do it as one giant task. And when I talk about refactoring, one of the first things I say is that ideally, I personally am not going to refactor any code until I've made sure that it's well tested. And it's not uncommon for you to be looking at a piece of code that doesn't have any tests. And actually, that's one of the things that's wrong with it, is that it doesn't have any tests. But it's very tempting to just leap in and start changing it without tests. And one of the things that I do and that I encourage other people to do is to write tests first. So I won't refactor anything until I've added tests. But adding tests to code that wasn't written with tests in mind, or that isn't well tested, or that isn't tested at all, can be a tricky task. So that's what this talk is about. It's about how you can add tests to code that doesn't currently have any tests. Because it's good fun and it's very satisfying to be able to refactor code in a safe way that makes you feel confident. And the thing is that once you have tests around a piece of code, that means you can change it and not worry about whether you've broken it. Because what you do is you make tiny changes, and after every single change, you run the tests. And if the tests are still passing, you haven't broken anything. And once you have a suite of tests in place, if all you're doing is making the code easier to understand and cheaper to modify, you're not changing its functionality. If you're changing the functionality, that's not refactoring. That's adding new features or fixing bugs. That's changing something. That's not refactoring. If all you're doing is making it easier to understand and cheaper to modify, and you're not changing the functionality, then once you've got a suite of tests in place, you shouldn't probably have to write any new ones. All you have to do is just make sure they keep passing. And that gives you this wonderful feeling of safety that whatever changes you make, as soon as you've made any change at all, run the tests. The tests are passing, great, you haven't broken anything. And that means that you're doing it safely and you can do it confidently, and it becomes very satisfying. And everybody's happy. So that's my son Felix on the left. He that video or GIF was made a few years ago now. So that was, I think he was 15 when he made that video. He's now 21. And this is him just a few weeks ago. So he's the one in the middle of the picture. He is now a professional circus performer. That's his current show that he's touring. He's working with a circus company called No Fit State in the UK, and the show is called Bamboo. All of those sticks that you can see are made of bamboo, and what they do is they construct a kind of playground out of bamboo, and then they climb all over it. It does actually look in the picture as though they've somehow attached strings to his extremities and they're pulling him tight. They're not. He's doing that entirely under his own steam. And the only reason I'm showing you that picture is because I'm a proud mum, and he's a professional circus performer, and I think that's brilliant. So there you go. So let's talk about using coverage to add tests. And for most of the rest of the talk, I am actually going to be doing some live coding. So let's hope that this works. So the first thing I need to do is just get up the code. I am going to be coding in C#. This piece of code, you may have seen it before. So this is the Gilded Rose kata. The code base is hosted by Emily Bates on her GitHub. I will share links at the end. They're in the useful links doc. And this is a piece of code that has been deliberately designed to help people practice refactoring. So it is deliberately bad code. That's the whole point of it, that the code isn't great. And there are lots of different exercises that you can do that Emily and I share what we call learning hours. Emily's got a YouTube channel where she shares learning hours. And there are loads of ways in which you can use the Gilded Rose kata as an exercise in refactoring. What I'm going to use it for today is to show you how you can add tests to untested code. The first thing I'm going to do is just show you how I look at coverage, because that's going to be crucial to how I progress. So I'm in Rider. IntelliJ IDEA for Java has similar tools, and lots of other IDEs for other languages have similar tools. I'm working with C#. The code is simple enough that you shouldn't need to panic if you don't know C#. In fact, if you know Java or JavaScript or Ruby, all of those languages are similar enough. And even if you don't know any of those languages, you should be able to get the basic gist, because there isn't anything particularly complex or language specific in this code. So the first thing that I'm going to do is I'm going to check the coverage of the tests that I do have. But let me show you what tests I actually have. And let me tell you a little bit about the code. So the idea is that there is a pub called the Gilded Rose. I think it comes from World of Warcraft. I don't play that game, so I don't know. But there's an inn called the Gilded Rose. And in this inn, you can buy various weird things. So you can buy aged brie, as in the cheese. You can buy backstage passes to a whatever the hell that says concert. You can buy Sulfuras, Hand of Ragnaros. You can buy legendary items. I don't know what any of these things are, and I don't need to. But what I do know is that at the end of every day, the quality of these items changes. And it changes according to various esoteric rules. So cheese gets more valuable as it gets older because it's maturing. Backstage passes get more valuable until the day of the concert. And then the day after the concert, they're worth nothing. So depending on the item, their quality changes over time. And there is this method called update quality, which gets called at the end of every day and updates the quality of all the items. And the code in this method is nasty. It's lots and lots of nested if statements. And you can see that if this is true, then this happens. And if this is true, then this happens. And all of the different items are all muddled up. And it's horrible code. They also have as well as having a property of quality, they also have a property called selling, which you'll see mentioned. There you go, selling. That's how many days it must be sold in. They also have a name. So they have three properties. They have quality, which is the thing that gets updated. They have a name, which tells you what the item is. And they have a sell-in value, which tells you how quickly they have to be sold. And that's it. That's all the information we have. And we know that this method gets called once a day to update the quality. We want to refactor this code because it's really difficult to extend. It's really difficult to modify. It's also really difficult to understand. That makes it really hard to work with. It means that we can't work with it effectively. It's going to be difficult to fix bugs. It's going to be difficult to add new features. And we're going to be really slow working with this code. So we'd like to be able to work with the code more effectively. Not only will we be slow working with it, we'll also not have much confidence as to whether we've broken things, because there aren't currently any tests. So what we want to do, the very first thing we're going to do, and the only thing I'm going to focus on for this talk, is I'm going to add tests to this code. Now, because this is designed as an exercise for people to do, we've very kindly given you a starting test, but it doesn't really do anything. In fact, it deliberately fails. So if I run all the tests, it's going to run this one test and it's going to fail. And the reason it's going to fail is because the very first thing it does at the start of the test is it sets up a list of items that only contains one item whose name is foo. And then it asserts that the name of the item should be fix me. Well, it isn't. It's called foo. So that test fails. So what I want to show you is that I can run coverage. So if I click just this little down arrow, so bottom left I am now, let me just wave my cursor around a bit. I'm at the bottom left of the screen and I've been clicking this green button here to run the tests. But this time I'm going to click the little down arrow to the right to get a little drop down, and I'm going to click cover all tests. And what that does is it runs the tests and it generates coverage statistics. Now, I've already got them up on screen because I already did this earlier. But if we look at the coverage statistics, we'll see that at the moment, it's saying that it has got 100%. And I think that might be because we haven't got this test passing yet. Because if we look at the code, yeah, I'm not quite sure why it's saying 100% there. That's slightly annoying. But if we look at the code, you'll see that we've got all of these red bars in the left. So that's red, that's red. And that's saying that that code is not covered by the test. And then we've got all of this grey areas, which are not really sure, but the red areas are saying, no, this code is not covered by our tests. The grey is saying it's sometimes covered. There are some paths that cover it. The red is saying, no, not covered. So at the moment, the test coverage is poor. This one test that we've got only tests a very small number of paths through the code, and they're failing. Okay, so the next thing that I'm going to do, actually, you know what? I think I might have read that wrong. Let's get them passing and then that'll make it easier. So I'm just going to make the test pass by saying that the name of the item should be foo, which it is. So that's going to make the test pass. I'm going to run it again with coverage. And now what I get, if I look at the code, yes, I did read that wrong. Apologies. What the red was saying was that this code is covered by tests, but those tests are failing. So it's covered by failing tests. Now the green is saying these areas are covered by passing tests. The grey areas are saying this code is not covered. So what we want, and there's a lot of that grey stuff. So the paths through the code that are taken by our test are not covering very much of this code. And that's what I want to try and fix. Because what I want to be confident is that you could take any path through the code and the tests would still cover you. So I'm going to try and improve that. So the first thing that I'm going to do is I'm going to actually make, yeah, there you go. So I've done that. I've made the test pass. And then the next thing I'm going to do is I'm going to start using the approvals framework. And the approvals framework is a really nice way of adding tests to untested code. This is also called the Golden Master. And I'll show you how it works. So I've replaced that one line of code that said check that the name is foo. And I've replaced it with this approvals.verify. At the moment, that is not even in the code. So I'm just going to do Alt Enter to say, yes, can you import that library, please? So now I've got the approvals library imported. And what the approvals library is doing is saying, I want to verify the name of the first item in my list, item 0. I've only got one item in my list, so currently that's all the items in my list. But I'm saying take the first item in the list and verify its name. Okay, but what does that mean? Verify the name. Well, let me show you. So the first thing I'm going to do, you'll see I'm not quite ready yet, because when I run the tests, you'll see it will complain. It will say, welcome to approval test. It's really nice, actually, the way this library works. It's saying, okay, brilliant. You've started using the approval test, but you need to add this decorator to your class in order for this to work. And it gives me nice, clear instructions for what to do. So I just need to add that to the test, and I can use my tools to import those libraries. So then I'll run the tests again. What that's doing is setting up a diff reporter, and you'll see why that's useful. So I'm running the tests again, and the next thing that happens is it brings up a diff reporter. So what this is saying is it's showing me the difference between two files, received.txt, which you can see here on the left, and approved.txt, which you can see here on the right. So let's have a look where they are. You'll see that what the code does is it passes item0.name to the approval tool. And if we go back to the diff reporter, you'll see there it is, the name of item 0. It's foo. And that has been put into received.txt. So what the approvals framework has done is it's create a text file called received.txt, and it has put the name of the first item into that file. Then, because I've just run this for the first time, it has generated another file called approved.txt, and it's just generated an empty file. There's nothing in it yet. But it's saying what I've received is just this one line with the name of this item called foo. And effectively what it's asking me is, would I like to approve that? And I'm going to say yes, actually. So at the moment, my test is very simple. All it does is ask for the name of the first item in the list, but the name is foo. That's correct. So I'm going to click the accept button. And what that does is just copy that into the approved.txt file. And if we go and have a look at our file system now over here, you'll see I've got an approved.txt and a received.txt. And because I've just made them be identical, if I run the tests again, they're going to pass. So that's why it's called approvals, because I've approved that output. I've said, yes, that's what I wanted. I wanted the name of the first item, and that's what I'm expecting. The point being that I could now change the code, and if that name changed, then this test would fail. But that's not terribly useful. All I'm doing is checking the name of an item. It's not really testing very much. So what I'm going to do is I'm going to make it a bit more sophisticated. So I've added the text into my approved file. The next thing I'm going to do, because I'm not only interested in the name, for the main thing I'm interested in is the quality, because I've got this method called update quality. So I don't want to just know the name. I want to know the quality as well. And also I'm interested in the sell-in value. I want to make sure that hasn't changed. So I've done here's one I prepared earlier. I've already got a toString method all ready to go in here. What this toString method is going to do is give me the name and the sell-in value and the quality value. So it means that if I go back to my test, and instead of asking for the name, I'm going to call this toString method, and that's the thing that I'm going to approve. Now, I've changed my test now. I've said that I'm now looking not just at the name, but also at the other values as well. And I'm actually just going to rename my test as well, so that it makes a bit more sense. So let's run that test again. What it'll do is it'll bring up the diff reporter again. And what it's doing is it's saying, I'm going to fail this test right now because the text that's being generated is the name and the quality and the sell-in value. And I'm going to say, yeah, oh, by the way, you'll see that it's got nothing on the right, which you might think, hang on a minute, didn't you put something in it a minute ago? I did, but then I renamed the test. And what it does is it names its approved file after the name of the test. So actually, new name means new approved file. But what I'm going to say is, yeah, okay, I like all of that. This is what I'm expecting. I think that if I have an item who has all of these values, then that's what I should get back. So I'm going to say, yes, please, that's correct. So now if I go and run the tests again, because I've updated the approved file, the test will pass. Great. But I'm still not testing very much. So let's have a look at what I am getting. So I am going to do a little bit more. Do I want to do that next? Yeah, I'll do that now. Okay, so I am going to do some things that are going to make this code, make me be able to do more with this test. I'm going to introduce something that I call combination approvals. But before I do that, there's a little bit of setup that I need to do. So I am going to introduce a variable. I'm going to use my refactoring tools. This is another thing that I really emphasize strongly when I'm teaching people about refactoring, is use the tools that your IDEs have. And it's a good reason to move away from tools that don't give you very much and towards tools that do, because they can be really powerful. Throughout this demo, I'm just going to bring up the refactoring menu, which on my Mac in this IDE is Command-Shift-R. I'm not going to use the exact shortcuts because I want you to be able to see them. So I could just have done Command-RV, but I've done Command-Shift-R just to bring up the refactor menu so you can see what I'm doing. And I'm going to use the introduce variable refactoring. So now I have a variable that I'm going to call item string. Oops. All one word, item string. That holds that value of the string that belongs to the item. So the item converted into a string. The other thing that I'm going to do is up here, when I create this new item, I give it 3 values here. I'm actually going to put all of that whole thing into a variable called an item. And then I'm also going to put all of that stuff into some variables. So I'm going to introduce variables for the name. I'm going to introduce a variable for the selling. At this point, it's clever enough to notice I've got 2 zeros, but I don't want to replace both of the, well, 3 actually. I don't want to replace all of them. I only want to replace one of them because that's the selling and the other one is not the selling. And I want to give them sensible names and I want to keep them separate. So now I'm introducing a variable for the quality as well. So now those have all got variables. Okay, so now I've got quite a lot of code. The next thing I'm going to do, and actually, because I'm distracted because I'm doing a demo, I forgot. I would normally, after every single change, run the tests. They run fast enough that I can afford to do that. But I haven't changed what it's doing, but I could have broken something. So, and I know my tests were passing, so I'm going to keep running the tests, make sure they're still passing. I haven't broken anything, inadvertently created a failing test when I didn't intend to. Okay, so now what I can do, now that I've done all of that, and this is, again, another common refactoring technique, because I've extracted these variables, I can now extract a method in a really useful way. So there are 2 things that I did there. Effectively, I extracted these 3 variables, and I also extracted a string variable, all of which means that if I now highlight these 5 lines of code and use the extract method refactoring, it will work out that the method I want to extract is probably going to want to have inputs and an output. And this is going to be really useful to me. So I've deliberately fiddled about with the code a bit so that then the tools will give me a method that has inputs and outputs. So now I've got this do update quality method. And what it does is it creates an item. It gives that item the name, selling, and quality values that have been passed in as inputs. It calls the update quality method. It then looks at the item again, does a toString on it to find out what its selling and its quality and its name look like, and return the result of that. So effectively, it's created an item called update quality and returned the results. I can now inline these 3 variables because I don't need them anymore. They were just temporary while they were a little trick that I could use to extract a method with good inputs. So I can inline that again, inline that again, and inline that again. So now, oops, what did I just do? Yeah, inline. I clicked the wrong thing. There you go, inline. So now I've just got 2 lines of code again. But the useful thing I've done is I've extracted this method. So the next thing that I can do is I can now bring in the concept of combination approvals. And again, I've got one I called created earlier that I'm just going to paste in. But basically, I'm now using combination approvals instead of the other kind of approvals. It's spotted that I need to import a new reference, so I'm just going to import that. And actually, I'm not using the old ones, so I can use the clever tools to say, okay, yeah, don't need that anymore, get rid of that. So now I'm using combination approvals. And what it's doing is it's saying, call this method do update quality that I created before for a lot of different combinations of values. At the moment, I've only got the same values that I started with. There's just going to be one item called foo, one quality value of 0 and one selling value of 0. And that's what it starts with. But I'm now going to be able to create combinations of values. So you can see it takes this method that I created as an argument, and it also takes all of these other values that I'm going to use to create my combinations of values. But before, let's make sure, again, I ideally would have been running tests more frequently because I just made quite a lot of changes. Again, I was distracted because I was in demo mode. Now this is failing. And the reason it's failing is not because I've broken anything, in fact, but it's because I've introduced combination approvals and they work slightly differently. So the output is even better than the output I was getting before, because the output automatically from combination approvals is it gives you the state of the object before and after. So it gives me the inputs that I passed into my method. So I created an object called foo that had a starting quality of 0 and a starting selling of 0. But after I called the update quality method, the name has stayed the same, the selling value has stayed the same, but the quality has changed. And that's the whole point, that we call update quality and it changes the value of the quality. This is a default object. It's called foo, which is actually useful information. Because when we look at the code, you'll see that when it has special cases for things like aged brie and sulfurous hand of Ragnaros, and they behave in strange ways. But other items, any other item with any other name, just behaves in the default way, which is that every day its quality goes down. So because we've called update quality once, the quality of this item has gone down by 1. So it's gone from 0 to -1. And all of our outputs are going to look like this now. So I'm going to say, yes, that's fine. I'm happy with that. I know that's what my output looks like. I'm going to accept that. I'm going to say, yes, that's good. So now when I run my tests, they will pass. So now we get to the point of the thing that I wanted to do, is that I want to check my coverage, because I've still only got one test that tests one type of object with one value for quality and one value for selling. And that's the only thing I'm testing. So if I now run the tests again with coverage, I can have a look and see what my coverage is like. And I can see that update quality. Oh, I see what I was doing. This is why it's okay. Why am I getting 100% in here? I'm getting 31% there, 79% altogether. If we look at the code, you'll see that there's still these large areas of code that are not being tested. So my figure at the top is saying 31%. That's the one I'm interested in. These other tests are a separate thing, but I've got 31% coverage here, which is not great. So I want more coverage than that. I want it to go higher than 31%. So what I'm going to do is I'm going to think about how I can increase the coverage. And there are some really obvious ways I can do it. So at the moment, my combination is only testing for one type of item called foo. And I can see very quickly that there are other types of items that are special cases and they're not being tested. So I'll go in here, I'm going to add to this array and I'm going to say, well, what happens if I test for aged brie as well? So now I can run the tests again with coverage. Give it a second and you'll see that it goes, I have to accept it. So that's the other thing with approvals testing, is now what's happened is, because I've given it some new test data, the output has also got new data in it. I have to approve that. I have to say, yes, that's good. This is not a failing test. It's just that I've rewritten the tests to include more data. So therefore, there are going to be new outputs. So I just accept that and I say, yes, that's correct. If I have an aged brie item that starts like that, then it should end up like that. And this is another important concept of approvals testing. I am assuming that the code I'm working with is correct. If there are bugs in the code, fixing those bugs is a different job and not the job that I'm doing now. I'm saying that this code is working exactly the same way it was when I started. I've not touched the code at all. I'm only writing tests around it. So I'm assuming the code is correct. And what I'm checking is whether I've changed the functionality or not. And I don't want to change the functionality. Okay. So I've accepted that. Now I'm going to run the tests again with coverage. They should pass. And we should also see that coverage number go up. Okay, it's gone up from, it's still on 31%. So let's see if we can get even better coverage. And probably the reason it's only on 31% is because actually there's a lot of stuff saying if it's not aged break. But let's try adding in backstage passes. So in my test data now, I am going to format this slightly differently so that I can see everything. And I'm going to add these backstage passes. Run the tests, and remember they will fail initially because I've just changed the test to add new test data. So there will be new data coming back from the code. I have to say, yes, I also want to test backstage passes. So I just accept that and say, yes, I'm expecting that new data. Run the tests again with coverage. And they should pass. And the coverage should go up. Okay, the coverage is not changing. If I look over here, it's because I haven't changed any quality values. So what's happening is it's not seeing the new quality. It's not going into the code because there's a lot of code checking. If quality is a certain amount, then don't do certain things. So I'm going to add in, if we have a look at the code, I'll just, for the sake of completeness, I will just make sure that I've now covered all of these possible strings. I think there's only 3 of them. Yes, I have. So now let's have a look at what else this code does. It asks quite often whether the quality is greater than 0. And in my test data, it never is. So I've only ever used a quality of 0. And what else does it want to know? It wants to know if the quality is greater than 0. It also wants to know whether it's less than 50. So how about we give it quality of 49 and 50. So we've got those 2 cases covered. So remember, the first time I run the tests, they'll fail because there's now new data. So I'm just going to run the tests. I'm going to see it fail, and then I'm going to accept the new data. So I'm going to approve the new data. So now we've got lots of combinations because we've got aged brie, we've got concert tickets. Oh, and I haven't added in sulfura, so I need to add that in as well. But we've also got all of those for these different quality values. And look how the quality changes differently according to what kind of item it is. So with aged brie, the quality is going down. And with the backstage passes, the quality is staying at 0. It probably means we need to fiddle around with the sell-in as well. But for now, I'm just going to say, yes, I'm happy with all of that data. I'm approving all of that. And now if I run the tests with coverage, they should pass. And hopefully my coverage is going to go up a bit. Okay, the coverage is not going up. I confess, I'm not quite sure why it's not going up. But if we look over here, we can see it is. There is something odd happening with my coverage results over here on the right. Apologies, it's the demo syndrome. Because if we look over here, we can see the coverage is looking really good. So we can see on the left-hand side here, the bars that I had in grey have actually gone. I'm not sure I have any grey bars left. So let's see. But what I haven't done is add any of this sulfuras Hand of Ragnarus stuff in. So let's make sure we've got those in. And also let's try some different sell-in values. So if we go over here, we'll see it asks whether quality is greater than 0. It asks whether it's less than 50, but it also asks whether sell-in is less than 11 and also whether it's less than 6. So, and whether it's less than 0. Quality is only ever worried about whether it's greater than 0 or less than 50. So let's add in some other sell-in values. Let's try -0 and 6 and 11, because they all seem to be important values. Run the tests again. They'll fail again because I've put new data in. And then I'm just going to accept all of this new data. I'm going to say, yes, I know there's a whole bunch of extra data now. And you'll see that it's working out all of it. It's really nice for thinking about edge cases, because it's trying all of these different possible combinations of values. And it's showing me very clearly what the inputs are and what the outputs are. So I'm saying, yes, I expect all of that to happen because I haven't changed any of the functionality. So I expect that all of that is correct. And now I'll run it again with coverage. Maybe it's that top figure that I'm interested in. I don't know why the coverage figures are acting a bit strangely. Obviously, I'll fix that before the next time I do this. Yeah. Okay. But if I look at the code, I can see that there were actually some end braces that weren't being covered before, but now I've got really good coverage. So I might think, brilliant, I'm done. I'm ready to start refactoring because I've got full coverage. Every possible path through this code is being tested. I'm actually slightly annoyed that my coverage statistics are acting weirdly, because I've remembered now that if I take the 6 out for the sell-in, run the test again, this will also change the output. So I'll need to approve the new output. Then if my coverage statistics were behaving themselves, I wonder if it's a caching problem. It might be because I ran all of this earlier. That might be it. Anyway, okay. So what I'm going to say is, yes, I've changed the data a bit. I'm going to accept all of that. And then I'm going to run the tests again with coverage. And I think the number that I'm interested in is this 100% test, this 100% up here. Yes, because Gilded Rose tests is a different file. But apologies for the confusion over that. But I do now have 100% coverage, even without that extra value in. And that's what I'm about to demonstrate, that this thinks it has 100% coverage. It thinks that every single line of code is being covered. It doesn't count the else statements as being lines of code. So it's saying all of these lines of code are covered. My cat has come now to lick my hand. But I happen to know, because I've done this many times before, that the coverage is not as good as it appears to be. So this is where the mutation testing comes in. So what I'm going to do is I'm going to say, okay, fair enough. So you're telling me I've got 100% coverage. I'm going to try and prove that, because if it's true that I've got 100% coverage, then that should mean that if I deliberately break the code, my tests should fail. And remember, the point of my tests are to allow me to refactor safely. So I want to be able to make changes to the code and then run the tests. And if I break the code, those tests should fail. And that's the whole point of them. They're to give me confidence that when I change things, I can keep running the tests. And if they pass, then I'm happy I haven't broken anything. So that means that if I deliberately break something, the tests should fail. And that gives me confidence in them. So I'm going to look at obvious places where I could make this code break. And look here, I mean, this is doing, given the whole point of this method is to update the quality. If I deliberately change the way the quality is being updated, then that should break the test. So instead of subtracting 1 here, I'm going to subtract 2. And then I'm going to run the tests. And this is why we're now into the mutation part of this demonstration. This is mutation testing. These tests are now failing. So you'll see down in the test area at the bottom, they've gone red. And what the diff reporter is saying is, look, your approved file says that you expect certain things to be happening, but that's not what we're getting. It's giving me the opportunity to approve those changes because it can't tell whether I just changed the test as I have been doing previously. But in this case, I haven't changed the test. I've changed the code and I've broken something. And I can see I've broken something because the output I'm getting is not matching my approved file. So you can see here, I've received the output of 46 where it should have been 47. So I know I've broken it. So I'm not going to approve those changes. They are not good changes. I'm going to put the code back to how it was. But I'm happy because my mutation has proved to me that my tests are doing a good job. So I'm going to undo the mutation. I'm going to make sure that I've put everything back to how it should be. So this is the equivalent of me trying a refactoring and then breaking things by mistake. So I'm reverting that refactoring. I'm saying, whoops, hang on a minute. I've changed something inadvertently. So good. Right. So that's fine. But what about down here? What about if I change this? Let's change this to a 2 instead of a 1. Again, what I expect to happen now, because I've changed the actual code itself, is that my tests should fail. So this mutation should cause my tests to fail. And brilliant. Yes, they are failing. I'm glad. I'm happy. It means my tests are fit for purpose. So I'm not going to accept those changes. I'm just going to revert the code back to how it was, run the tests again, make sure that they are now passing, which they are. Brilliant. Okay, so what about if I do the same down here? Here's another place where I can change. I'm going to change that to a 2. And this should cause my test to fail because I'm changing how the quality is being updated. But the tests are not failing. So this mutation has now exposed a deficiency in my tests. It's also a really nice illustration that test coverage on its own does not guarantee that you are giving your code a full workout. The reason this is happening is to do with something that happens lower down in the code. So what's happening is the quality is being incremented by 2 up here. But down here, the quality then here, I think, the quality gets set down to 0. We don't need to worry too much about exactly why it happens. I know why it happens because I've looked at this before. But basically, the code is all being called. So this, for certain cases, this code is being executed. But even though the code is being executed, the result of that code is being overwritten by something that happens down here in some circumstances. And what we've done in our test code is we haven't captured those circumstances. If I have a look at the code, I can see that there is this thing that I spotted before where at one point it says, what if the selling value is less than 6? So 6 appears to be an important value. So I'm going to add that into my test data. It won't affect the coverage as far as the coverage tool is able to calculate it, but it does mean that I'm now exercising values that I wasn't exercising before. So if I now run the tests again with this new value in, so the first thing I have to do is run the test, because if you remember, that's now going to mean that the output is going to change because I've added new data into the test. So there's now going to be outputs that include what happens when the sell-in is 6. So this is new data. So I need to approve those changes first of all, because all I've done is edit the test. I haven't edited the code under test. So I've edited the test. I've approved the changes. Now I run the tests again. I just make sure that those tests are passing with new data. They are. So now I'm going to go back. I'm going to find the place where I was at before, which was this here. Oh, okay. It's a good thing I made this mistake, actually, because it's an easy mistake to make and it's worth highlighting. I deliberately introduced a mutation, but then I left it there by accident. I need to revert the mutation. I need to make that go back to +1. Now, what's going to happen when I go back to +1 and run the tests again is they're going to fail because I just accepted false data. So now I have to say, oh, actually, no, that wasn't quite right. Right. So it's just that one value that's different, but I need to make sure that that is now, using the correct data. So run the tests again. And that shows you what a small edge case it was that was affected. But now I can see the code is back to how it should be. So the only thing that's changed is that the test data has changed. I've accepted the new output into my approved file, and now my tests are passing again. So now I'm going to go back and I'm going to say, which I effectively just illustrated just now, but I think that now if I change that one line of code and run the tests again, the tests should fail. And the only thing I've changed is the actual code under test rather than the test. I'm not going to approve that because all that's doing is proving to me that my tests are now fit for purpose. So I need to make sure I revert that mutation, run the tests again, make sure they pass. There's another example that I can show you in this code that also there's another mutation I can make that will also highlight problems. And if you notice, the mutations that I'm making are just anything that updates the quality. So I'm going around and I'm fiddling around with the things that update quality. And I'm checking if I change the code that updates quality, does it break things? Because it should. And if it doesn't, then I know I've got a problem. So actually, I can change quality again down here, run the tests, see if they fail. And they don't, so that's good. Make sure I revert the change and run the tests again. And there's one more place I can introduce a mutation in here where it's updating quality. I think, or there might be a couple of places actually, but what about down here? If I change that value, run the tests again. And I think this is another one that will expose a deficiency in the tests. So the tests are failing. So I'm not going to accept that change. But what I am going to do is think about, oh, okay, let me make sure I revert the mutation. And then I can think about what else I might want to change. So at the moment in my test data, I'm testing -1, I'm testing 11. But what I'm not testing is something that's greater than 1, greater than 0. And the reason that's important is because there's a line in the code that resets, that subtracts 1 from the quality. So it gets down to 0, and then it asks whether it's greater than 0 or not. So if I add in 1 to the test data, so remember, the only thing I've changed is the test data. I haven't changed the code under test. Let me check that I didn't. Yeah, I put the code under test back. Change the test data, running the tests. Now I need to accept the new test data. So I accept that in a few places now because I've just added some new test data. So I just accept all of those. There might be an accept all button somewhere, but anyway, there we go. Accepted all the changes, run the tests again so that I can see them pass with the new test data, and then go back and introduce a mutation again. And now I think this should cause my test to fail. And if it does, then again, I know that my tests are now better. They're capturing mutations in the way that they should. Okay, undo the mutation, and they did. They failed, which is good news. So I've undone the mutation, put it back to how it was, run the tests, make sure they pass. Now, I've done all of this manually, and the reason I've done it manually is to demonstrate to you how it works. But you can get various tools that will do mutation testing for you. So what the tools will do is they'll test many different combinations of values, looking at the code, looking at what values might be important, testing the mutations, finding out where the mutations are relevant, and adjusting your tests accordingly. But I quite like doing it manually because it demonstrates exactly what's happening, how it works, and why it works. Okay, I think I've officially reached the end of my time.